All right, here we are with higher order derivatives. The main thing here is that the notation is one of interest. Notation. So we'll start off with f. We have f of x. First, higher order derivative. Well, what is it? It's a derivative of a derivative. In a context that makes sense. If you start with a function, you might want to find the derivative of that function, and then find the derivative of another function, of that same function, the derivative of the derivative. You might want to find the derivative of the derivative of the derivative. So that gets a little confusing after a while, unless you have names for these things and notation to fit it. So higher order derivatives are just derivatives of derivatives. So for instance, we might start with f, and we're going to have our first derivative, we call it. Now notice it's called the first derivative. We never called it that before, but now that we know there are more than one derivative, this one's called the first. The second derivative, of f is f double prime. First derivative of f is f prime. So now the second derivative of f is really just the derivative of f prime, first derivative. So you just build them as you go through here. You can't get the third derivative unless you have the second. You can't get the second unless you have the first, because you build them. So that's if we have our function notation. If we just have y, then we'll work with y prime, y double prime, and so forth. And we can have a third derivative, by the way. Third derivative of f is f triple prime and y triple prime. Now, another notation is called the differential notation. We could have dy dx. That's our first derivative. Second derivative is written like this. And we really don't say this. In other words, there's no way to describe this. You just call it the second derivative when you see these symbols like this. This one, people do call it dy dx, but it's also known as the first derivative. This one, they really don't call it anything but the second derivative of y with respect to x. And that's all you can say about it. There's no shorter way to say that. And of course, you could have a third derivative, which would look like this. Okay, so different notation for that differential notation. Now you also can work with without this function here. Variation of that just looks like this, d dx, or you can have this, or like so. And then you would put in whatever function here you're trying to differentiate. Like it might be an f of x, it might be, yeah, it might be an f of x like that. So it's more handled like sort of like an operator, where it operates on something. Okay, so that's the notation you'll see in this first course. There's a couple other variations of this, but we won't use them in this course. More useful for multivariable calculus. There's a single variable, so you'll see some of these. Now, find the second derivative of f of x. That means second derivative is f double prime. Okay. Now, by the way, just a quick mention. If you go past triple prime, typically you don't use the primes anymore. You might use Roman numerals like that. That would be the fourth derivative. Fifth derivative looks like that. If you don't like Roman numerals, you can also just write a little 4 like that, but it has to be in parentheses. You could do a 5 like that in parentheses. So that's probably easier than using Roman numerals, but it's the same. Okay. So in case you get higher derivatives, 4, 5, and so forth. All right, back here, we're going to find, we want the second derivative, which is this. Okay, so we need the first derivative. Let's get that. Quotient rule. Derivative of the numerator times the denominator minus derivative of the denominator times the numerator, all divided by denominator squared. And then we'll go ahead and simplify. 2x squared plus 2x minus x squared minus 2x plus 1 x squared, which is, looks like an x squared plus 1 over x squared. Okay. Now we want a second derivative, so I'm going to take it over here, f double prime. Also notice that I often leave off the function notation itself, the f of x, f double prime of x. This is commonly done. I know it's lazy, but if I'm not going to evaluate this function any place, then why do I need to drag around the whole parenthesis, x parenthesis? So I don't, and most people don't when you get through this. So let's go with the second derivative. We want derivative of the numerator, which is a 2x, times the denominator, minus derivative of the denominator times the numerator, all divided by denominator squared, so that's a 4 exponent. Okay, so here we have 2x to the third, minus 2x to the third, minus 2x over x to the fourth, which is just a minus 2x over x to the fourth, which is a minus 1 over x to the third. So derivative got simpler, didn't it? So that's our answer for the second derivative. Okay, looks like the third derivative would be pretty easy to get at this point. All right, now let's find another problem here. In fact, since I talked a lot in this one, I think I'm going to just call it quits on this video, and we'll go back to another one for the rest of it. So see you in the next video.